So in this video, we're going to look at imaginary numbers, and I'm going to try to make this a quick video just to give you a few examples. But essentially, an imaginary number is written with the letter I. Okay, and simply put, an imaginary number is the square root of a -1, or I stands for the square root of -1. So we can basically use imaginary numbers to do negative square roots. Like if I wanted to do the square root of -9, unless we add in imaginary numbers, I can't really do this. It's, I don't know, it can give me something like undefined, or I don't know, whatever the calculator would give you. Maybe it could give you like a domain issue or something like that. But what we can do, if we use I is equal to or stands for the square root of -1, what I can essentially do, if I get any square root, I can take out the negative by just putting I on the outside. Because once again, the square root of -1 is equal to I. So like if I do the square root of -9, the first thing I can do is take out this negative and replace it with I. Then I can do the square root of 9 just like normal and say the square root of 9 is 3. So the answer is 3I. Because remember, anything on the outside of a radical is multiplied by whatever joins it on the outside. So there's a quick example. We can do another quick example just to get us the idea, or give us the idea. We could say the square root of -196. So once again, the first thing I can do, this negative I can take out and make I. Then I can do the square root of 196, and the square root of 196 is just 14. So this would become 14I. All right, now let's look at this in terms of solving a problem. Because I've already uploaded a few videos over this, like solving quadratics. We're going to solve a quadratic by square roots. And you're going to see that when we do this, it's going to leave us with a negative under the radical. So like, let's try x squared plus 81 equals 0. And let's say I want to solve this with square roots. Well, I'm going to subtract 81, because I want to isolate x squared. I'm going to say x squared is equal to, just let me draw this a little bit straighter. There we go. X squared is equal to -81. And now you're going to see when we square root both sides, we get x is equal to plus or minus the square root of -81. And I have to use imaginary numbers, or the I notation, in order to deal with this negative under the radical. So once again, here's what we can do. To do the square root of -81, we can take out this negative and make it I on the outside. Then we can just leave 81 as a positive on the inside. Then the square root of 81 is 9, so my answer to this would be 9I. So then here's how we would write that, at least in terms of this problem. X equals plus or minus 9I. All right, let's look at another example. So let's say we have 2x squared plus 9 equals 1. All right, so once again, we're going to solve this by square roots. So we know we're missing this bx term. That's how we could also know we're solving by square roots. Well, we can solve by square roots. So we're going to subtract 9 to start isolating x squared. So then we're going to divide by 2 to continue isolating x squared. So then x squared is equal to -4. And now you can already kind of see when we do the square root of this, we're going to end up doing the square root of a -4. So once again, this is where we have to use that I in order to account for this negative under the radical. So once again, this is where imaginary numbers is so helpful. Because a lot of times I get asked, why do we need imaginary numbers? And this is where we need it. So we can say x is equal to plus or minus. Once again, this is going to give us an I on the outside. So I radical 4, the square root of 4 is 2, so this would give me x equals plus or minus 2I. All right, so now let's look at one more quick portion. So what if I have a square root like this? Let's say I have the square root of -32. Well, here's the first thing you're probably wondering. or here's the first thing we could do, and then we'll worry about what you're wondering. So first thing we could do is take out this negative and make it I on the outside. Now, here's what I'm hoping you're starting to look at and say, well, I can't do the square root of 32. So this is where we actually have to break down our radical. So we could break down this radical, but this I is just going to stay on the outside. So we could break this down into the square root of 16 times the square root of 2, because remember, we want the biggest perfect square that divides, 32. So that would be 16, and then the square root of 16 is 4. We would have 4 radical 2. But then we just have to throw in this I with 4, and that would be my answer, 4I radical 2. All right, so we can still simplify radicals even if it's a negative number. So like, watch this example, because this is where this example is needed. Let's say I have x squared plus 13 equals 1. All right, so we're going to solve this by square roots. We're going to subtract 13, and we're going to say x squared is equal to negative 12. So now hopefully you're saying, well, when I square root this, I'm going to end up with x is equal to plus or minus the square root of a negative 12. All right, but once again, here's what we can do. The first thing with this square root negative 12 we can do is take out this negative and make it I radical 12. Then we can continue and we can break down what's in the radical just like we've done in the past. We can keep I on the outside. We could break down the square root of 12 to the square root of 4 times the square root of 3, because 4 is the biggest perfect square that divides 12. And then we can take out the square root of 4, which is 2. We can put I next to it since it's just a variable at this point. And then we can leave the square root of 3. So then our answer would actually be written like this. Before I circle it, we would say x equals plus or minus 2I radical 3. Which once again, it seems like a lot, but that's exactly how this problem would work. So let's do this. Let's just do one more just so you can see what this looks like. So let's do 3x squared minus 5 equals negative 446. So this problem looks pretty crazy, but once again, we can do the same steps. We can add 5. We can say 3x squared equals negative 441. Then we can divide by 3. We can say x squared equals negative 147. Now, that looks like a crazy big number, but we'll be able to take care of it when we square root both sides. We'll say x equals plus or minus the square root of negative 147. So now, what we can do is take out this negative, make it plus or minus I radical 147. And then the square root of 147 we could break down, and we could make that 49 times the square root of 3. So this is actually going to end up giving us x equals plus or minus square root of 49 is 7. We bring down our I, and then radical 3. And that would be our answer. So once again, this is where imaginary numbers are useful. I'm going to actually upload another video to handle one more part of imaginary numbers. But this is where imaginary numbers are very useful for us. They help us to do negative radicals.